For problem number 3, we're given f again. This function is graphed right here, and it's defined only on the interval from 1 to 6. Determine whether the following statements are true or false. If the limit exists, give its value. The limit as x approaches 1 from the right. Right? From the right, here's 1. We're approaching it from the right. It looks like about 3.5. So that's a true statement. It's about 3.5. How about 2 from the left? Here's 2. As the function approaches, x approaches 2 from the left, the function is heading towards 2. So that's true, and the answer is 2. How about 4 from the right? Here's 4. We want to approach 4 from the right. That's leading us vertically towards 4. How about 6 from the left? Here's 6. We're going to approach 6 from the left. Yep, that works. Again, it's 4. The limit as x approaches 1 of the function exists. Well, this is false, because I know what the limit is as x approaches 1 from the right. I have no idea what's happening over here as x approaches 1 from the left. That's a false statement. The limit as x approaches 2 of the function exists. Well, get out my secondary pen. I'm approaching 2 from both sides. Are they on a collision course? Yes. So that's true. And they're looking to meet vertically at 2. Even though the function's value is 1, that doesn't matter. It's what happens as x approaches 2. And vertically, we're up here. Does the limit as x approach 3 of the function exist? Well, here's 3. Yep, it does. They're going to meet up there at 5. So that's true, and it's 5. How about the limit as x approaches 4? 4 from the left, down here. 4 from the right, up here. My two pen tips are not near each other. That's false. The limit as x approaches 5 exists. Here's 5. Yep. For left and right, same spot, 6. The limit as x approaches 6 of the function exists. This is the same thing as e. We can't find the limit as x approaches 1 of the function or 6 because we don't know what's happening from both sides. All right, and then underneath that we have the piecewise defined function. We have to find the following limits for number 4. The limit as x approaches -1 from the left. These are numbers that are smaller than -1. Smaller than -1 means we use x cubed. So we're using like -1.0001, which is so close to -1 that we can basically just use -1. So this is equal to -1 cubed, or -1. How about the limit as x approaches -1 from the right? These are numbers that are slightly larger than -1, like -0.99999. -0.99999 falls in this range right here. So we have to use the middle function. But again, -0.99999 is so close to -1, we can just use -1. So we have 2 times -1 plus 1, which is -1. So does the limit as x approaches -1 exist? Well, from the left it's -1, and from the right it's -1, so yes it does. This limit is also -1. Now let's check out D, E, and F. The limit as x approaches 4 from the left. That's a number that's just smaller than 4. We're still in this range right here. If we plug 4 in here, we have 8 plus 1, right? 2 times 4 plus 1. That's 9. That's my limit as x approaches 4 from the left. 4 from the right is like 4.0001. That's bigger than 4. I have to plug 4 into this part of the equation. So that's going to be equal to 1/2 times 16. That's equal to 8. Does the limit as x approaches 4 exist? Well, from the left we're heading towards 9. From the right we're heading towards 8. Not the same number. Limit in general does not exist.